Hello, and thanks for joining us. This is Astronomy Daily. Andrew Dunkley here, your host. Hope you had a good weekend. And I hope you had a good weekend too. Halley, how are you?
Hi, Andrew. I hope you got through the flooding okay. They're in Dubbo.
Oh, yeah, it was nothing really, Halley. As usual, the popular press making a mountain out of a molehill.
So, there wasn't any flooding?
Well, the river did rise, yeah, and it got over the main one of the main bridges briefly, and we had a few road closures, just precautionary things. But it wasn't a catastrophic flood by any means. But that didn't stop the seagulls.
Seagulls?
Yeah, the TV news services flying in their helicopters, all trying to scoop each other for a major flood story. It was a bit silly, really, but that's how it is, I guess.
I see what you mean. Seagulls, that's funny.
Well, that's what they are. They swoop in, they get the chips, and then they leave. Anyway, never mind. We're just getting on with it here.
The Astronomy Daily Podcast
with Andrew Dunkley.
So what's happening in astronomy news, Halley?
NASA has set a date for the next launch attempt of Artemis 1. It looks like being September 27th, but it all depends on that fuel test next week, so no guarantees at this stage. The Perseverance rover on Mars continues to do a fantastic job, and the latest is that some of the rock samples it has collected have been analyzed and there is evidence of organics. But, to fully understand what has been seen, the rocks will have to be returned to Earth, and that might be some time. A green fireball was seen streaking across the United Kingdom last week, and while many thought it was a meteor, experts believe it might have been space junk. Lots of footage was taken by people with mobile phones, dash cams and doorbells. The study of Saturn's rings has thrown up a possible explanation of how the planet's rings might have formed. They now believe that the rings are what is left of a moon, which has been named Chrysalis. They still have a few mysteries to solve though, including the planet's severe tilt and the way it wobbles. Not long now until the DART mission's greatest moment, when a spacecraft is crashed into the moonlet of an asteroid. The double asteroid redirection test is seen as a potential solution to any future asteroid threat to Earth. The goal is to alter the orbit of the moonlet. The impact date is September 26th. And Thomas Zurbuchen is calling it a day as the head of NASA's Science Missions Directorate. NASA will be looking for his replacement later this year. Thomas has worked in the role under 3 NASA administrations and 3 presidents. And that's the news, Andrew.
Thanks, Halley. We'll talk to you again before we finish up today. Now let's see what else is happening in astronomy and space science. A new agency involving 3 groups to coordinate the US missile defence space programs has been established. They are the joining together of the Space Systems Command, the Space Development Agency, and the Missile Defence Agency. So there's a new program office which will coordinate the procurement of satellites to detect ballistic and hypersonic missiles, according to Washington. The Space Systems Command, the Space Development Agency, and the Missile Defence Agency have created a program office. Now, for many decades, the Missile Defence Agency has been in charge of deploying sensors and interceptors to protect the US and its allies from ballistic missile attack. The Space Force took over from the Air Force in the development and procurement of geostationary missile warning satellites. And in 2019, the Pentagon decided to invest in low Earth orbit networks of space sensors to track hypersonic missiles fielded by Russia and China. So putting it all together, the combined program office will bring more unity into those efforts, basically. Walter Chai is the director of space sensors at MDA. He said in a statement, with the emerging advanced threats, space-based sensors are essential to missile defence. The close collaboration between SDA, SSC and MDA will ensure that we're able to defeat these threats. Now, I don't think there are too many of us that haven't watched with interest for the last 45 years the voyages of 2 space probes, Voyager 1 and Voyager 2, which are fast departing our solar system. Some say they already have passed the heliopause, but as Fred Watson told us in Space Nuts a few weeks ago, the heliopause moves. So sometimes they're out of it, sometimes they're in it, and backwards and forwards it goes. And there's no denying what an incredible mission it has turned out to be and lasted a heck of a lot longer than most people thought. But now there is a bit of thought being put into a new mission that might just surpass the incredible achievements of the Voyager probes. A team at the Applied Physics Laboratory have put forward details, a proposal to NASA for a mission concept that may be even bigger and better than Voyager. It's called the Interstellar Probe, and the craft would be able to travel even further than the Voyager missions. And it will, obviously still be sent out there to find the answers to questions about the heliosphere, which is that bubble-like region of space that shields our solar system from galactic radiation. If the interstellar probe does come into being, the mission could end up breaking its predecessor's record as the most distant human-made object in the universe. But let's have they do it. I think it's a great idea. Now, Halley might be thrilled to hear this. Artificial intelligence has detected a stream of stars in the universe that extend for thousands of light years across the Milky Way, according to Princeton University. The Pleiades cluster is a cluster of stellar nurseries where thousands of stars are born from clouds of dust and gas and then disperse across the Milky Way. Now, for hundreds of years, scientists have been speculating about whether these clusters always form tight clumps like the Pleiades, spread over only a few dozen light years. Then 2 years ago, a machine learning algorithm using data from Gaia, the Gaia satellite, identified that many far-flung stars are moving at the same speed and direction and could therefore be part of the same open cluster. Well, now a team of astrophysicists led by Luke Baumer have confirmed that one of these streams of stars, NGC 2516, also known as the Southern Beehive, extends for at least 1,600 light years or 500 parsecs from tip to tip.
The Astronomy Daily Podcast
with Andrew Dunkley.
Now, we often talk about the potential for life in worlds beyond Earth where there are oceans, where there is water, and we've got a few prospects in our own solar system with the likes of Ceres, Enceladus, and a couple of other places. Well, now it's come to us. A meteorite has fallen into the Cotswolds area of the United Kingdom. To be specific, it landed in somebody's driveway. No, I'm not kidding. And the meteorite has been examined and they have found water in it, extraterrestrial water. I guess you're wondering what that water is like compared to what we have on Earth. Well, I don't know if it'll be disappointing or exciting. Depends how you look at it, I suppose. But it closely resembles the water we have on Earth, according to the scientists who did the study. The Winchcombe meteorite was comprised of water that is very close to that we find in our own oceans, and it does add more evidence, I suppose, or supports more of the theories behind life on Earth being seeded by meteorite strikes. The Winchcombe meteorite was originally part of a larger carbonaceous asteroid which formed around 4.5 billion years ago from the leftover planet-building material in the early solar system. Now, it contains about 12% water, which is locked up in the minerals, sort of like mud, and scientists believe that carbonaceous asteroids were probably the main source of water on Earth. Well, that just about wraps it up for our first day this week. Halley, you got anything before we go?
Yes, Andrew. Did you know that space isn't actually silent?
No, well, I know we heard the sound of a black hole recently because it was constructed or something to that effect. I can't remember the details, but I always thought that you couldn't, there was no sound in space. Is that wrong?
Well, according to NASA, the pitch of the sound generated by the black hole in the Perseus cluster translates into the note of B-flat. But a human would have no chance of hearing the cosmic performance because the note is 57 octaves lower than middle C.
I have trouble hearing something 1 octave below middle C, to be honest. But, that's just me. I'm always being accused of being deaf. Thank you, Halley, and we'll catch up with you tomorrow.
Okay. Bye.
And we're done for the day. Thanks for listening. Don't forget to go to our website, spacenuts.io, and click on the Astronomy Daily tab. You can subscribe there to the free newsletter. You can also read more about the stories we've talked about today. And we'll be back again tomorrow with another episode. Until then, this is Andrew Dunkley for Astronomy Daily.
The Astronomy Daily Podcast
with Andrew Dunkley.